All right, so this will be the last video. If you're watching the videos thinking this is taking a long time, just remember you watch, if you come to class, it's going to be an 80-minute lecture, but you watch the videos, I guess it's going to be about 40 minutes, 35 minutes, and you get a whole class of time, a whole class time of, a whole 80-minute class to work. So I think you're getting, I think you're getting a good deal. No, this is something stupid, sorry. All right, evaluate an exact form. So we can evaluate this using our unit circle because 20-degree angles are not angles on the unit circle, unfortunately. 30 are, 60, 45. We can even now do 15 degrees and 75 degrees with our new formulas, right? But still, 20 degrees and 40 degrees are not going to work. But if you look at this expression, it's exactly in the pattern of our identities. And again, I'll swing back here just to show them to you. So the sum of the sines, sum of two angles for the sine is sine, cosine, cosine, sine, same sign. And for cosine is cosine, cosine, sine, sine, change of sign. So if we, and this is a kind of a pattern recognition, if we can get something like this on the right, for an expression, then we can work this backwards. It goes both ways. So this one is sine, cosine, cosine, sine, same sign. So this is the sine. So this is equal to the sine of sine, cosine, cosine, sine, same sign. So it's just going to be 20 degrees plus 40 degrees. So it just happens to be exactly the right side that we can work this way. 20 degrees plus 40 degrees is 60 degrees. And now I can use my unit circle. The y coordinate at 60 degrees is the positive square root of 3 over 2. So if you recognize patterns, you can kind of go backwards. And this can be verified on your calculator if you wish. I'm not going to do that. Oh, by the way, if you watched the other video, I was kidding around by holding the VARS key and it having voice activation. I just thought that would be funny, but whatever. We'll see if you guys watch the video and comment on it. Last example, verify the trig identity. So I got the cotangent of x plus y equals, it kind of looks like the tangent, only we got cotangents and they're kind of the denominators in the numerator and whatever else. But there are actually identity formulas for the cosecant, the secant, and the cotangent. So you might think it's bad that you have to memorize these 6, but there could be 6 more. We could give you a total of 12. But we don't really need to memorize these because we can use these to calculate those. So this is an example of that. So this is the cotangent, the sum of two-angle cotangent identity. Let's verify it. So we're going to start with one side. Now normally I would start with this side because it's more complex, but I'm going to have a really hard time getting it back to this because I don't have a formula for that. So on this one, we're actually going to start with this side and write it as a tangent and then use our tangent identity. So I'm going to start with the left-hand side. I'm sorry, I don't know why I do this. I know if anyone else watches these videos, they're going to say, that's stupid to write LHS. You don't have to, but you do have to start with the left-hand side without changing it at all. Well, I'm going to use the reciprocal identity. This is the tangent of x plus y. Now I'm going to use my tangent identity. Long fraction bar. So the tangent is tangent of x plus tangent of y all over 1 minus the tangent of x times the tangent of y. Now I need to make this look like this. So I guess let's first get rid of the fraction, I guess. Equals, we got 1 over 1 times that multiplied by the reciprocal. So basically the bottom moves up to the top. And the top goes to the bottom, I guess. Spitting on my screen, that's gross. Tangent of x plus tangent of y. Now normally I would not change the tangents into cotangents, but this is our goal. This is where we're working towards. So those have cotangents. So every place we see a tangent, let's write it as 1 over cotangent. So 1 minus This can be 1 over the cotangent. I'm just going to go cotangent x, cotangent y. 1 over cotangent, 1 over cotangent, put it all on the bottom. This is 1 over cotangent x plus 1 over cotangent y. All right, so let's combine our fractions and then multiply by the reciprocal, all that goodness. Common denominator here, so this is cotangent x, cotangent y minus 1 over cotangent x, cotangent y. And this is going to be multiplied by cotangent y, so this is going to be cotangent y plus, this is cotangent x, over the product, cotangent y, cotangent x. Now, and it's fine if you guys can see this too. I don't, you get good enough with fractions, you kind of realize that those are just going to cancel, and we're actually done. Please don't cancel. So if you wanted to, I would be fine going from here to the last statement, cotangent x, cotangent y minus 1 over cotangent x, I think it's, write it exactly like this. So I'm going to put the x first. Cotangent x plus cotangent y. My proof is done. Or take the top fraction multiplied by the reciprocal, cancel those, whatever you want to do. But this is fine. I can follow that. So this is the formula for the cotangent, but thankfully we don't have to memorize that. All right, good luck. Hopefully you watch the videos and get some really good work time in. Work with your friends, work with your other people in the class, ask questions of each other, work together and try to figure it out. Good luck.